Video will talk about estimation and order selection for ARIMA models. The technique that is used for estimating ARIMA models is called maximum likelihood estimation. Once we have identified the model order, which is how many autoregressive components would the model have, or the degree of differencing the model would have, or the order of differencing, and the order of the moving average processes that the model would have, we need to then estimate the parameters, which are C, and then the different phi's and the different thetas. So phi's correspond to the autoregressive component, and the thetas would correspond to the MA component. Now, we're talking about something that we do after we have understood what the model order is going to be, but actually we're going to get to thinking about what the model order is going to be after we think about the estimation, just for the sake of simplicity for now. So the maximum likelihood estimation is very similar to the least square estimation that you do in regression analysis by minimizing the sum of squared residuals, okay, for the entire time series. In both cases, nonlinear optimization is used, and different software might give you different estimates, but those estimates would be somewhat close to each other, so you don't have to worry about it. But so we're just going to be sometimes we might even have a case where one package in R might give you a different result, and another package might give you another result, so don't worry about that. But how do we get to understanding what type of order would our model have? One useful thing that you have seen before, or one useful graphic, is looking at partial autocorrelation. So I do think it's a good time to review those notes and those videos for now. So partial autocorrelations measure the relationship between yt and the lag values of yt. What you essentially are doing is you are looking at a regression like this, where y is regressed on the past values of itself, and in each case you get a phi. Okay, so this is the autoregressive parameter, phi1 through phi k, and these phis are called partial autocorrelations. Partial because it's basically like doing regression and saying, well, what is the effect of yt minus 1 on yt, holding everything else constant, okay? And so this is a partial effect that phi1 is capturing, and so on and so forth. So that's what it is. So your partial autocorrelation is going to shed some light on what type of order does the ARIMA model have, okay? Now, there are different and more efficient ways of calculating these partial autocorrelations, and softwares take care of it. And to understand whether these partial autocorrelations are significantly different than zero, there are some confidence bands that you would see around partial autocorrelation functions once we look at the graph. So when those bands that we see cross the Bartlett bands, then we can say that those are significant partial autocorrelations. So let's take a look at this graph, which is talking about mink trappings, the annual number of minks trapped in thousands over time. So this does look like it's going, it has some kind of a cyclic pattern maybe, and therefore we can take a look at what the autocorrelation functions and the partial autocorrelation functions look like. So here on the left panel you have the autocorrelation function, and on the right panel you have the partial autocorrelation function. Now the partial autocorrelation functions typically point to what is the order of the autoregressive process that you should think about, and the autoregressive and the autocorrelation function points to the MA order that you should think about. Okay, so in this case we can say maybe because one lag here is significant, and then there's another one at lag 4, maybe an AR process of order 4 is a good guess for this type of a time series. Or an MA, if you look at the ACF, this is actually showing you a pattern, okay, some kind of a pattern, a cyclic pattern over time. And because these are, these are years, these are not seasons. So this is some sort of a cyclic pattern that you're seeing. Anyway, what we can do is we can also take a look at using this really nice command called gg_ts display. We can take a look at the value of the time series along with its autocorrelation function and the partial autocorrelation function. So if you want the partial autocorrelation function here, you can actually say value, comma, you have a plot type option in which you can mention what type you want. Now let's take a look at what are the interpretations of the autocorrelation functions and the partial autocorrelation functions. For a stationary process, the autocorrelation functions would exponentially show a decay, so they would tend to zero very quickly. Whenever you have an AR1 process, you would see a single spike in the partial autocorrelation function, which is why partial autocorrelation functions are very good to infer the order of the autoregressive process. Now, in general, if we were thinking about an ARP process or the autoregressive process of order P, the autocorrelation function dies out in an exponential or damped wave in a sinusoidal manner, in a sine wave manner. And the partial autocorrelation functions has pretty much all zero spikes. It may not be zero, it might all be insignificant spikes beyond the pth spike, okay? So if you have an AR2 process, then you would see 2 spikes in the partial autocorrelation functions that are significant. If you had AR3, then you would see 3 spikes in the partial autocorrelation functions, and so on and so forth. So, but nothing beyond that pth spike in the partial autocorrelation functions. For an MA process, it's reversed. The partial autocorrelation function will show you an exponential decay, and there is a single significant spike in the autocorrelation function. Okay, so very different. This is all opposite. Okay, so when you want to infer the MA order, you want to look at the spikes in the ACF and whether the PACF is showing a decay. So just to wrap up, the MA order of Q would show you that the PACF is dying out in an exponential or damped sine wave manner, but the autocorrelation function has all zero spikes or all insignificant spikes beyond the Qth spike. So if it was an MA process of order 1, then you would see 1 spike that would be significant in the autocorrelation function.